Okay, so in this recording, we're going to look at redox and assigning oxidation numbers. This is the first step in any redox equation, to go ahead and assign your oxidation numbers. Remember that oxidation number is just another way of describing the charge that an atom or ion has. So an atom obviously would have a zero charge, and then an ion would have some sort of positive or negative charge based on how many protons and electrons that particular element has. So some of the groups on the periodic table, we know what the oxidation number is, and we know what those are always going to be. So for example, group 1A is going to be +1, group 2A is going to be +2, group 3A is going to be +3. For anything else, we have a list of rules to follow. So the rules for our other elements include atoms of elements are always going to be 0. Protons and electrons are equal, so they have no overall charge. Monoatomic ions are equal to their charge. So if it's a, say, for example, N-3, that nitrogen is going to carry a -3 charge. If it's a Zn+2, that particular zinc is going to have a +2 charge. So basically, if a charge is given, that's what the charge is for an element. Fluorine is always -1. Very, very rarely do I say always in chemistry, but fluorine is always -1. Follow that up with oxygen is usually -2. Most of the time you're going to see it's going to be -2. If it's in a peroxide, it's going to be -1. And if it's paired with fluorine, the fluorine is going to force it to become +2. Because again, fluorine is always -1. Hydrogen is +1. Unless it's paired with a metal, then it's -1. So for example, sodium hydride, NaH, the sodium would be +1 and the hydrogen would be -1. The sum of the oxidation numbers in a neutral compound must equal 0. So you're just going to add your positives and negatives up and you're looking for it to equal 0. If you have a polyatomic ion, then the charge has to equal the charge on that polyatomic ion. All right, so let's look at some examples. These are not very difficult. All right, so for the first one, we have SO2. So we don't have a rule for S, but we do have a rule for O, that oxygen is usually -2. So I'm going to put a 2 here. There's 2 oxygens. So in this compound, the overall charge on the oxygen is going to be -4. So in order for this to equal 0, because it's a neutral compound, because no charge is given initially, whatever I have for the sulfur has to make this equal to 0. So if the oxygen has a total of -4, then the sulfur has to be +4. And since there's only one sulfur, then that sulfur itself is +4. So my answer would be S +4, O -2. Okay. For the second one, this one I do have a charge. So instead of making it equal to 0, like I did in my first example, I'm going to have to make it equal to -2. So the charge on the oxygen is -2. That makes the charge overall for oxygen -6. Remember, I'm trying to make this equal to -2. So what does the carbon have to be in order for this to be -2? It's going to have to be +4. And again, since there's only one carbon, the carbon itself is +4. So C +4, O -2. All right. Na2SO4. So we've got a couple different things going on here. Na is in 1A, so we know the charge of it's +1. Another way you could also look at this is you know that this is sulfate. Sulfate has an overall charge of -2, and because this is +1, that's why this has a has a 2 on here, because we had a drop and swap. So there's a couple different ways you could figure this one out. So if the sodium is +1 and there's 2 of them, +2. The oxygen is -2, there's 4 of them, -8. In order for this to equal 0, what does the sulfur have to be? So right now with just these 2, we're sitting at -6, so this is going to have to be +6. So my answer is going to be Na +1, S +6, O -2. All right. For the NH4, we've got hydrogen, which is +1, so +4. And for this to equal 0, what does the nitrogen have to be? It's going to have to be -4. So N -4, H +1. All right, we'll do a couple more examples of these, and then we will move on to our next topic. So there it is. For this one, NH4 in parentheses 2S. So a couple different ways, again, that we can look at this. We know that this is ammonium. It's paired with something else, so we know that this normally carries a +1 charge. If this is +1 and there's 2 of them, the whole reason it's +1 is because the sulfur is -2. So -2, and then we know hydrogen is +1. And this time, because of the parentheses, 2 times 4 is 8. So this has a +8 charge. So in order for this to have an overall charge of 0, what does my nitrogen have to be? Well, right now I'm sitting at +6. So this is going to have to be a total of -6. But what you have to remember is that there's 2 nitrogens. So if it's overall -6 and there's 2 of them, this has to be -3. So N-3, H plus 1, S minus 2. Okay. All right, for number 6, SF6, this is an easy one. Fluorine is always -1. There's 6 of them, -6. So that means to make this 0, the sulfur has to be +6. So S plus 6, F minus 1. All right. This one is another easy one. So this is a monoatomic ion. The charge is given. So that's what it is, S minus 2. All right. And then our last one here, NO3. So the oxygen -2. That makes this -6. I need my overall charge here to be -1. So what do I have to make the nitrogen in order for this to be -1? If I'm already sitting at -6, then this is going to have to be +5. So +5 and -6 equal -1. N plus 5, O minus 2. Okay, so like I said, this is the first step in all of our redox problems, is assigning these oxidation numbers. I'm going to go ahead and do a second video where we look at writing half reactions, and then I'll do a subsequent video with the balancing by that half reaction method.